Okay, it's time to talk about another exciting subject in Simon's high-tech basic molecular biology and genetics lectures. Okay, we're going to talk about dominant and recessive mechanisms here. So, first we have to realize, of course, that we have a dominant and a recessive mechanism, and we're talking about the gene product, to whether or not the mechanisms are working or not, whether there is sufficient information to make the gene work in its intended use. So when we talk about loss of function, for example, we might say that loss of function is usually recessive, and that a mutation leads to an inactive gene product. But reduced activity, a reduced activity level is still sufficient. However, if the reduced activity is not sufficient, then the phenotype is deemed dominant. Now, it's a little confusing, but we have to talk about something called Haplo Insufficiency. Haplo Insufficiency means that there's just not enough gene product to make the gene work, and then it's just not effective. But haplosufficiency means that the gene is working enough, and then you have sufficient gene power to make it do its job. So a little bit confusing here, but just remember that you have loss of function, and that there could be haploinsufficiency or haplosufficiency, but that it's usually recessive, and the mutation leads to an inactive gene product, but reduced activity level is still sufficient. Confusing here, yes. Anyway, let's move on. Let's talk about gain of function. Gain of function is for a novel action, and there may be an altered mRNA expression, and an increased or a decreased protein activity. So we're talking about an overexpression here with this gain of function. And let's talk about dominant negative. So dominant negative, we're talking about a mutant case here, and this is an abnormal function that interferes with a normal allele. For example, an example of this would be collagen mutations in osteogenesis imperfecta. So obviously this is a mutation, and we would call this dominant negative. So this is a mutant. The gain of function is only in dominant cases, but loss of function is usually recessive. So if you want to think a way to remember it, is that loss of function is recessive, and gain of function would be dominant, and the dominant negative is mutant. So I hope that you understand that, and we're going to move on to another subject. But before we move on, we do have to talk about one more subject, and that is incomplete dominance and codominant alleles. Incomplete dominance, think of a pink rose. In this case, for incomplete dominance, the phenotype is heterozygous and is different from that seen in both homozygous genotypes, and its severity is intermediate between them. What does that mean? So the phenotype is heterozygous. So you might have a white and a red allele, but neither one of them is strong enough that it's going to overtake the other. So it is different than that is seen in both homozygous genotypes, when both are the same. But what is happening here is like one is leaking into the other, so you end up with pink. The opposite is codominant alleles. In this case, the expression of each allele can be detected even in the presence of the other. An example of this would be AB blood and that the A is just as strong as the B. So there's an example. So you have codominant and incomplete dominance. Thank you.